Okay, so what we're going to start learning about today is called piecewise functions. So what piecewise functions are, it's one function, but it's going to use different pieces of two different functions, and then where each piece is graphed on one graph is going to be based on the x values of that piece. So for example, we have f of x, and then f of x is representing just one function, but it's going to contain pieces of both of these functions. So it's going to contain pieces of x plus 1 and pieces of negative 3x. The thing that you have to pay attention to is where each piece goes. So anytime that you have an x value that's less than 2, you're using that first equation, x plus 1. If your x value is 2 or more, then you're going to use the second equation. So pay attention to where you have the equal to line in that. So like you have the greater than and then the equal to under. That means that if the equation, or if it's asking for the value at 2, you're going to use the second equation because of the equal to line. So there's going to be a couple of different things to look at. But the biggest thing that I want you guys to look at is evaluating these. So we're going to try to evaluate these three at the bottom here. So the first one is f of 0. So if you notice that the 0 here is in the same place as the x is in here. So that's saying that we're going to be using 0 as our x value. So then what you have to do is look at your intervals, and you see that 0 is going to be less than 2. So since 0 is less than 2, you're going to use the first equation, x plus 1. So instead of the x, you're going to plug in 0 for x and then do plus 1. So that means that you're going to get f of 0 equals 1. And that's it for that one. So then moving on to f of 4, that means x equals 4. So where x equals 4, that's going to be greater than 2. And so that means you're going to be using the second equation for this one. So on this one, you're going to have negative 3 times x, and we know that x is 4. So that means f of 4 is going to equal negative 12. And then our last one is the one we were talking about earlier, f of 2, so x equals 2. And because of the equal to line, that means we're going to use that second equation again. So you would have negative 3 times x, and then in this case we have x equals 2. So that means f of 2 is going to equal negative 6. So the next thing I want you guys to see is just what a graph of these would look like. So we have this absolute value graph here, and then we have a quadratic graph. So one thing that you can do is just make a table of values around where the graph is going to split. So when I say split, I'm talking about like where the intervals split. So in this case, the intervals are going to split at x equals 1. So I'm just going to put a line right here at x equals 1 so that we can see like where the graph is going to change. So then I'm going to start looking at some different numbers. So for this, for x is less than 1, I'm going to start plugging in some numbers around like negative 2, negative 1, 0, and I'm going to plug in a 1 as well, even though it's not actually in that interval. So I'm just going to make a table, and I'm going to have x and f of x. So for x, let's actually start at negative 3, negative 2, negative 1, 0, and 1. And we're going to definitely stop at 1 because we're not going to go any further than 1 in that first interval. So starting at negative 3, you would have the absolute value of negative 3 plus 2 and then plus 3. So negative 3 plus 2 is going to be negative 1. But then when you take the absolute value of that, that's going to equal positive 1 plus 3 is going to be 4. So then if I do negative 2, I'm going to have the absolute value of negative 2 plus 2 plus 3. So negative 2 plus 2 is just going to be 0. The absolute value of 0 is also just going to be 0, and then plus 3. So 0 plus 3, we're going to get 3. So then negative 1, we would have the absolute value of negative 1 plus 2 plus 3. Negative 2 plus 1 is just going to equal positive 1, and then the absolute value of positive 1 is still going to be 1, and then 1 plus 3 is going to again be 4. And so then I have 0, so absolute value of 0 plus 2 plus 3 equals 0 plus 2 is going to be 2, absolute value of 2 is 2, plus 3 is going to be 5, and then I'm going to go ahead and plug in the 1 just to see like where the graph is going up to. So 1 plus 2, absolute value, plus 3. 1 plus 2 is 3. Absolute value of 3 is 3. Plus 3 equals 6. So I'm going to start graphing these points. So I have the point, and let me do this in red. I have the point negative 3, 4. So I'm going to go to negative 3, 1, 2, 3, 4. And then I have negative 2, 3 is right there. Negative 1, and then back up to 4. 0, 5 is right here. And then we need to go up to where x equals 1, but we don't want to actually use the value there. So what we're going to do instead is put an open circle where the point would be. So it would be at the point 1, 6. And so then we have this piece, our little absolute value graph. And then you guys know the absolute value graphs. It's going to be that V shape, and it's just going to keep going in that left-hand direction like that. So then I'm going to scroll down a little and change my color, and then I'm going to keep going with my x and f of x numbers, and I'm going to see what the graph looks like where x is greater than or equal to 1. So first, I'm going to plug in 1 again, because that's where I need to start. So I would have negative 1 minus 2 squared plus 5. So then 1 minus 2 is going to be negative 1, squared is going to be positive 1, but then there's a negative out front, so it would just be negative again. So negative 1 plus 5 is going to equal 4. And then I'm going to do a couple more here, so I would have negative 2 minus 2 squared plus 5, and I would get 2 minus 2 is 0, squared is still 0, negative is still 0, and then plus 5 is just going to be 5. And then for 3, I would have 3 minus 2 squared plus 5. And so 3 minus 2 is 1, squared is still 1, and then I make it negative, so I would have a negative 1 plus 5 again, and I would get 4. And then I'm going to go ahead and do where x equals 4 as well, so I would have negative 4 minus 2 squared plus 5, and I would get 4 minus 2 is 2, squared is 4, and then you have to make it negative, so negative 4 plus 5, and that's going to equal 1. So the points that I got from that, and I'm just going to write them down so that I can scroll back up, are 1, 4, 2, 5, 3, 4, and 4, 1. So then I'm going to scroll up here, and I'm going to actually plot those points. So I had 1, 4, and this time I can actually, whoa, sorry about that, not sure what happened. Let's erase that. I don't need this line anymore either. Okay, so I had 1, 4, and this time I can go ahead and actually put the point there. I can do a closed circle because we have that equal to line under greater than or equal to 1. And then I had 2, 5, and 3, 4, I believe it was 4, 1. And so then if you keep going with that, that's creating this little upside down parabola piece. So it's going to look something like that. And then I also want to show you guys how to do that on Desmos, just because it's a lot faster. So I'm going to go to Desmos and show you that as well. Okay, so I've got my two pieces of the graph put in like equations over here, but I haven't put my intervals in yet. So the way that you're going to do that in Desmos is you're going to start one of these little, I call them curly brackets. And so the first one, it was x is less than 1 was your interval. And then you see that it cuts it off right here for you. And if you click on the point at 1, it says it's undefined. Because it's less than 1, it's not less than or equal to 1. But as you start moving along, you can see that it has points for the rest of them. And then on my second one, I need another curly bracket, and I need x. I'm going to use my little math keypad so that I can get greater than or equal to. And then I'm going to put my 1 in there and do another curly bracket to end it. And you can see my little upside down parabola. And then if I click on 1, it tells me I have the point 1, 4 because we are including 1 in this interval because it's greater than or equal to. So that's kind of how you do it on Desmos. The only thing is it's not going to give you that open circle right there. It's just going to show you that it's undefined if you actually click on it. So keep that in mind, and if you're ever graphing them by hand, then you're going to want to put an open circle at the end of that absolute value v, where x equals 1. So then I just want to do a couple more examples where you're evaluating for these. It tells you to evaluate for x equals -8 and x equals 5. So we're just going to do the first two here. So we're trying to find f of -8 and f of 5. So starting with -8, we're going to look at our intervals that it gives us, and the first interval is less than 0. The second interval is greater than or equal to 0. So for the -8, we know that -8 is less than 0. So we're just going to do 2 times the -8, and we should get -16. Okay. Let's make that a little prettier. -16. Okay, and then for f of 5, since 5 is greater than 0, you're going to plug it into the second equation. And the second equation, it just says 0. So since it just says 0, your answer is just going to be 0. If there's not an x to plug anything into, then you just write the number and you're done. That's your answer. So then on the second one, this equation is called g of x. So we're looking for g of -8 and g of 5. So for -8, that's going to fall into our first interval up here because -8 is less than 5. So we're going to plug -8 into 2 minus x, with x being -8. So then 2 minus -8, if you're subtracting a negative, it becomes a positive. So it'd be the same as 2 plus 8, which is 10. And so then for 5, we're actually still going to use the same interval because it's greater than or equal to, less than or equal to. But since we have that equal to line under there, that means we want to use the first interval and first equation for 5 as well. So we would have 2 minus 5, and that's going to give us -3. So I hope that the couple of extra examples that we did, I hope that helps out. And then just let me know if you have any questions about evaluating these or the graphing. The evaluating is going to be like the more important piece of it, but I did want you to see how it works when you're graphing as well. So if you have any questions about any of this, then just let me know.